So I'm going to tell you exactly what happened to us in FD, New Jersey when we broke 2 differentials and what Winters did to take care of that problem. This is one of the original Winters Performance rear differentials. This is a 10-bolt design. It's the very first diff that I actually got from them. We still have one here that I'm holding on to for another project. But you can see that the difference in the casting right off the bat, we have a whole different forging process on the new diff. The old diff is actually, we never had a problem with these ones. It was the diff that actually came into play during the pandemic. So the Winters Performance has been using the same foundry for 20 years. And then as soon as the pandemic came around, they were having fulfillment issues. And so Winters decided to move their foundry to a new location. And what happened there is that there was not as much consistency with following through the casting process. When the new foundry started building their diffs, they started to find porosity in the castings. And that was actually discovered because the first differential broke in 2022. So it was about 2 years after they changed the foundry. And then from there, it just started to seem like this can of worms opened up and diffs started breaking left and right. Winters was doing a good job at keeping up with it and being true to their word, and they were replacing the center casing for anyone that did break their differential. They were starting to discover that the issues that they were having were not being able to be remedied fast enough, and they had to come up with a whole new design, a whole new casing, and a whole new casting process, which is where we land with this one here. You can see it's a whole different diff design. They just went back to the drawing board once they started to have those issues. Instead of just trying to redo the process with the casting, they just went right to a whole new casing, which has more strength, more durability, more webbing. They have a whole new forging process that's going to give a lot more strength on it too. But on these old diffs, you can see that this is the weak point on these differentials where they were breaking was right here, the part that kind of connects the quick change section to where the ring gear is. The pinion rides up on this upper half, and so it was actually cracking here, and this would separate, and then it would just go downhill from there. To also help remedy that, they included some extra material inside the casting in this problematic area, and then they even removed material in other areas so that the overall weight of the differential stays the same. Not to mention the aluminum that's used for the casting is triple ceramic filtered, which gives a much pure material to start with, and they got rid of the old sand casting method and are now using permanent mold casting process, which gives tighter tolerances and gives a much more consistent result every time. With steel molds, you're able to heat and chill targeted areas of the mold to control how the molten metal solidifies as it cools. Also, instead of hand ladling molten aluminum into the sand molds, permanent mold casting uses a mechanical tilt pour method where the entire mold is upended to allow the metal to flow inside without a lot of sloshing around and agitation. The combination of a controlled pour and controlled cooling virtually eliminates the porosity and density inconsistencies that were inherent in sand casting. The A356 T6 aluminum permanent mold castings have tensile strength, yield, and elongation properties that are stronger than sand cast aluminum by 13%, 35%, and 43% respectively, and stronger than sand cast magnesium by 13%, 103%, and 67%. In addition to the new permanent mold center section castings, they developed a forged 2014 T6 aluminum side bell that's as stout as they come. The new bells are based on a near net shape forging, and what this means is that the mounting surfaces are machined. The rest of the forging, like the critical crown of the bell, remains as forged. Machining forged surfaces cuts into the grain structure that's been established by the forging process, which exposes the grain ends and makes the parts more susceptible to cracking and fatigue. Additionally, the use of 2014 T6 instead of the 6061 T6 bells available elsewhere provides mechanical property increases of 56% better tensile strength, 50% better yield, and 8% better elongation. The difference in the differentials is still up to you when you go to purchase one. You can either get the 1310 or the 1350 front yoke. You can do the 108 or the 130 side flanges for different axle applications. You can do the 31 spline or 35 spline input shafts for more strength, and the standard or the 350M lower shaft for maximum strength. And so we always go for the top. So we got the big shafts, we got the big spline outputs, we got the big front yoke, and of course the 350M lower input shaft. And we have never had a problem with our differential. We've never broken one. Even going all the way back to our original diff, which we never broke, never had a single component fail on, even with the smaller 108 output flanges, the 31 spline inner flanges. We did always run the 1350 front, and this one actually has the non-350M lower input shaft. So they're tried and true all the way from the beginnings of our quick change days until now. And we're just really stoked to see Winter's Performance stay true to their word and come back and make a bigger, better diff for its customers. Yeah, back in New Jersey when we had our differentials failing, Winters actually drove out and brought the components with them to fix our diffs on site. They rebuilt 2 diffs in our trailer for us, one that went back into the car and then one that went back into our spare subframe. So just their customer service has been unmatched by anybody else, and which is why I'm sticking with Winters Performance.